Hello everyone, welcome to In 5 Minutes. In this video clip, we will do one numerical based on frequency selective filters. The question says sketch the frequency response and identify the following filters based on their pass bands. So there are two filters given. For the first filter, they have given us the unit sample response, which is h of n. And for the second filter, they have given the transfer function or system function, which is h of z. So let's do this one by one. First, we will consider h of n. You can see that length of h of n is 2 because there are only two samples. So it's nothing but finite impulse response. That means FIR filter. Which doesn't matter because we can have FR as well as R. Both the filters can be low pass, high pass, band pass, etc. So we have to first sketch the frequency response and then we will identify what is the type of the filter. To sketch the frequency response, we will require frequency response function, which is called h of omega, which can be obtained from h of z by putting z equal to e raised to j omega. So let's first find out the z transform of the given filter, where the definition will be summation h of n into z raised to minus n. N will vary from 0 to infinity, generally for causal signals. If h of n is not causal, then we can also start from minus infinity. All the practical filters must have causal sample response, and hence n will start from 0 for them. Now here there are only two samples. For n equal to 0 it is 1, and for n equal to 1 it is minus half. So this will be h of 0 into 1 plus h of 1 into z inverse, and therefore my h of z for the first filter becomes 1 plus h of 1 is minus half. So basically this will become 1 minus half into z inverse. To get h of omega, all I'll have to do is put z equal to e raised to j omega. This will make it h of omega equal to 1 minus half e raised to minus j omega, which can further be written as h of omega equal to 1 minus half e raised to minus j omega will be nothing but cos omega minus j sin omega, which will have real part as 1 minus half cos omega, and its imaginary part will be minus minus will become plus j half into sine of omega. If I draw the magnitude response will be nothing but mod of h of omega. So magnitude response will become magnitude of any complex number will be nothing but real part minus the imaginary part. So 1 minus half cos omega square plus imaginary part square will be 1 by 4 sine square omega. So this is what I get. Now if I expand this, you can see if I expand this, it will be 1 minus 2 1 into half cos omega, that will become under root 1 minus 2 and half will cancel out, so I'll be left out with cos omega plus 1 by 4 cos square omega plus 1 by 4 sine square omega will be nothing but 1 by 4, because cos square omega plus sine square omega will be 1. So therefore mod h of omega will become under root 1 plus 1 by 4 will be nothing but 5 by 4 plus cos omega. So that's my magnitude response. So let us now plot this magnitude response. To plot this particular response, we will have to make one table. Now in this table, I will consider various values of omega, and I will have to find out the values of mod h of omega, which has come out to be under root 5 by 4 plus cos omega. So let's take various values of omega. Now I'll start omega from 0. The range of omega is from minus pi to plus pi. But for causal and real signal, the magnitude response will be even function, and hence I can find out the values for 0 to pi. H of omega will be exactly same for the values of omega from 0 to minus pi, because it turns out to be the even function.